lecture we are going to discuss the third method of generation of single sideband with suppressed carrier. We have already discussed our two methods of the generation of single sideband with suppressed carrier in our previous lectures. So in this lecture we are going to discuss the third method, which is known as Weaver method, and this method is also called third method because just the third generation. So in this method we are using four balanced modulator and then Hilbert transform, two Hilbert transform with each of the balanced modulator. This is basically the enhanced method of the phase shifter method. So you don't need to remember even the whole diagram, but at least you need to know that how to analyze this block diagram. Like if this block diagram is given, then you need to know how can you calculate the input of single sideband suppressed carrier, how can you calculate S of t. So this is the balanced modulator and its input is 2 cos pi fmt, which is the message signal, and after taking the Hilbert transform of message signal, you are giving that message signal to the balanced modulator. Hilbert transform of that is sine 2 pi fmt, and then this message is again, so you are taking cos 2 pi f naught t. So we are having this condition that f of c is greater than f naught and f naught is greater than f of m. So carrier is multiplying with the cos 2 pi fmt at the balanced modulator, and you will get x1t. After that you are using low pass filter whose cutoff frequency is f naught by 2, and then you are sending that message to the balanced modulator, which is called y1t. So give this name y1 of t and then y2 of t. And then y2 of t is the input at the balanced modulator, and again another carrier cos 2 pi fc plus f naught, and these two are the input of this balanced modulator, and then you will get v1t. And similarly this is the load channel as well, and then here you are adding these two together, and then you will end up with the S of t, which is single sideband suppressed carrier. So what is x1t? So x1t is the product of cos 2 pi fmt and cos 2 pi f naught t. Cos 2 pi f naught t multiplied by cos 2 pi fmt. So which is the trigonometric formula 2 cos a cos b. So you can use 2 cos a cos b, so which is equals to cos a plus b and then plus cos a minus b. So we are using the same formula here. So cos, so this one is a, so this one f naught is a and fm is b. So 2 pi is common in both of them, so cos 2 pi a plus b and then cos 2 pi a minus b, f naught minus fm. So after passing x1t through the low pass filter whose cutoff frequency is f naught t, so this frequency is lower than f naught t, this is the higher frequency, it will not allow to pass this, but this signal will pass. So y1t we have 1 over 2 cos 2 pi f naught minus fm, and then y1t is the input at the balanced modulator, and cos 2 pi fc plus f naught is also the input at the balanced modulator. Now v1t, so v1t is the product of y1t and this signal. So v1t is half cos 2 pi f naught minus fm multiplied by cos 2 pi fc plus f naught. So again this is the same formula, like 2 cos a plus 2 cos a cos b. So cos a plus b, cos a minus b. So but in this case, so your a is, that is your a and that is your, so b. So a plus b, so cos 2 pi, so 1 by 2 multiplied by 1 by 2, the answer is 1 by 4 here, because you are going to add extra 1 by 2, so 1 by 2, 1 by 2, 1 by 4. Cos 2 pi f naught minus fma plus b, fc plus f naught t, cos 2 pi a minus b, so fc plus f naught, fc plus f naught minus, and then this is minus, this become a. So let's suppose this is low, so better to take it b, and then this one is a. So A, so this is A and then this is B. So minus Fm minus minus plus. So this is Fm. So this will be cancelled out. So you have Fc plus Fm. So this you have 2F naught plus Fc plus Fm. So so take it as A naught, the equation A. Now come to the next channel, x2t. So x2t is again multiplication of sine 2 pi fmt, and because you are taking the Hilbert transform of this cos 2 pi f naught t, so the Hilbert transform of that is cos 2 pi f naught t. So sine 2 pi fmt multiplied by sine 2 pi f naught t, again the same procedure. So 1 by 2 sine 2 pi f naught plus fm plus sine 2 pi f naught minus fm. So similarly here, so this is f a, this is b, so a plus b, and similarly a minus b. So you are having these terms. So after the low pass filter, so whose frequency is f naught t, so it means that it will allow to pass this signal, it will not allow to pass that signal. So we have 1 by 2 sine 2 pi f naught minus fm. So while 2t is basically the output of the low pass filter, so which is the input at the balance modulator, and then the other input at the balance modulator is the Hilbert transform of cos 2 pi fc plus f naught. So sine 2 pi fc plus f naught multiplied by y2. So again you are getting the same thing, like using the same formula. So you are getting cos 2 pi fc plus fm minus cos 2 pi fc plus 2 f naught minus fm. So you are adding a and b, so st, so this st is the addition of v1 and v2. So if you are adding v1 and v2, so you know the other sign is cancelled. So this is minus cos 2 pi, similarly this is plus. So you see 1 by 4 plus, so this is 1 by 4 minus, so they will cancel each other. So this is plus and this is plus, so it will become 2. So 1 by 4 multiplied by 2, the answer is 2. So like here it will be 1 by 4 multiplied by 2, so 2, so 1 by 2, remaining cos 2 pi fc plus fm. So you see this is the upper sideband. So this is the upper sideband signal. So that is the single sideband suppressed. So that is the upper sideband of the message. But so if you want to generate the lower sideband, so in order to generate the lower sideband, the second carrier, so this carrier, so like here instead of writing plus you can add minus, and then this will be minus, and then here rather than doing addition, here you are doing subtraction. So if you are doing subtraction, then you will end up with the signal which is lower sideband. So that is the third method, or the Weber method, for the generation of single sideband suppressed carrier. Now come to the demodulation or detection of single sideband suppressed carrier. So we are again using the same synchronous detector method. So what is synchronous detection? Balanced modulation followed by the low pass filter, because we are doing detection, so that is why it is low pass filter. Balanced modulator, the input is the single sideband suppressed carrier and the other is locally generated carrier, so which should be synchronized with the transmitter carrier. XT, so XT is basically the message signal multiplied by the single sideband suppressed carrier. So this is the general expression of the single sideband suppressed carrier. So cos square t, so we know that cos square omega t is equals to 1 by 2, 1 plus cos 2 omega ct. So this is sin omega ct, cos omega ct. So that is 2 cosine alpha. So that is 2 sin A, and then cos B, so which is equals to sin 2, so which is equals to sin 2. So cos sin A, cos A, so which that is equal to 2 sin A. Cos omega, in both cases it is omega ct, so A is constant. So after that, so you are having this signal, so m of t by 2 cos 2 pi f of ct, cap of m of t by 2 sin 2 pi f ct. So the spectrum of this signal is fm, the spectrum of this signal is 2 fc plus minus fm, and the spectrum of that signal is 2 fc plus minus fm. So if you pass that signal through the low pass filter, you know, no, this is not allowed to pass, this is not allowed to pass, this will pass because the low pass filter has a frequency which is centered at FM. So that is why after passing the low pass filter, you will end up with y of t, which is m of t divided by 2, which is your message signal. So in this way, you can recover the single sideband suppressed carrier demodulated signal like the message signal. I hope you understand the modulation generation of the single sideband suppressed carrier as well as the detection of single sideband suppressed carrier from these lectures. But if you still have any question, you are most welcome to write a question in the comment box and we will try our best to answer your questions. Thank you for watching the video.